what I want to start off with today is showing how that works with our supply and demand framework and work through an example. So externalities can be both positive or negative. So one thing you might want to highlight from the definition I gave you last time was that it could be a cost or a benefit. So there's a positive externality and a negative externality. And I think what we'll do is go through an example of a negative externality. A negative externality. So this would be a cost borne by a third party not directly related in a transaction, going back to our definition. And so let's go back to our beer market. And in the production of beer, Budweiser emits a chemical into the air that drifts down to a neighboring town of Crybaby. And the reason Crybaby's crying is that the babies are starting to be born with a third eye. So this chemical, so there's three eyes that are actually tearing up in the town of Crybaby. The chemical causes a third eye. All right. So what is the impact of this? What is the real problem? So if we go back to our market for beer, just like we did in chapter 3, so the quantity of beer and then dollars, the price of beer ultimately is where we're going with this. There's a good old demand curve and a good old supply curve. We've now learned that the supply curve is the marginal cost curve. And so it reflects the cost of an additional case of beer. And the demand curve is the marginal benefit curve. And it reflects the benefit that consumers get from each additional case of beer. The law of diminishing marginal utility gives us a downward sloping demand curve so that people aren't willing to pay as much for greater quantities of beer, downward sloping demand. And meanwhile, Budweiser, due to the law of increasing cost, has to get a higher price if they're going to be supplying more, the law of supply. So the happy little story that we told before we learned about kids with the third eye is that this quantity of beer is society's most efficient quantity. So if the market clears at 100 cases of beer selling for $18, the equilibrium price and quantity that the free market kicks out is good, is what we said. This is the failure now of the market because the market is not taking into account the detrimental impact in the town of Crybaby. So look at that definition for an externality. It's a cost borne by a third party not directly related to the transaction. So the babies here with the third eye are not buying the beer. So they don't have any control over it, right? That's the third party part. The transaction is between Budweiser, the company producing the beer, and the consumers of the beer. That's the transaction. And we have a third party that's being harmed by that transaction. Okay, so what comes about with externalities is that the social costs are not reflected in the private cost like we assumed. So up to this point, we assumed that the marginal benefit equaled the marginal social benefit. So we're identifying some new things here. The MB curve, the marginal benefit curve, i.e. the demand curve, those who are wanting to buy beer, the benefit that they get from drinking beer reflects society's benefits of drinking beer. Got it? So we're all on this island together. The island has a whole bunch of people that we started off with. And our goal is to make ourselves as happy as possible given society's limited resources. The market provides a mechanism to transform scarce resources into final products, into beer. And then this is taking a step further than saying the people who are drinking beer are members of society. The benefits that they get from that good reflects society's benefits. All right, so this MB curve that we've been talking about can be thought of as the marginal private benefit. These are the people directly related to the transaction. The social benefit takes into account all people in society. So the marginal social benefit takes all people in society into account. Those two things are equal when there's no externality. But when we have somebody else that's being affected by the transaction, this equal sign no longer holds true. We broke the link to that. So the last thing to add on to this little statement here is with an externality, and in this case, in fact, let me be a little more specific, with a consumption externality, because I'm talking about the consumers, the demand curve, the benefit. With a consumption externality, the benefits that are accrued by the people involved in the transaction do not equal society's benefits. All right. We assumed the same thing for production. So in general, again up to this point, with the free market, our baseline assumption is that the marginal cost to Budweiser equal the marginal social cost to society. So Budweiser is part of society. So if we go back to our market system, we've got businesses over here that are really a collection of the people over here. We all are on this island, right? And so the cost that the company incurs by buying the scarce resources of land, labor, capital, and entrepreneurship, those costs of production that we spent a lot of time in Chapter 9 looking at, with average total cost, marginal cost, fixed cost, variable costs, all those costs reflect the true cost to society. With pollution, that's not going on. There's an additional cost that's not being reflected in the production of that good. The pollution is not being taken into account by Budweiser. So again, with an externality, in fact, let me get a little more detailed here to tie it back to our example. With a negative production externality, i.e. like pollution, if the pollution's coming from the plant, the way we described, the marginal cost for Budweiser does not equal the marginal social cost. All right, this brings us back to our graph then, and we can start to see how things are screwed up. The market is producing 100 cases of beer at $18. Is that more beer or less beer than what would be ideal for society? Is that too much beer or too less beer? Which do we want? Do you think there needs to be more beer because of the pollution or less beer? Less, right? So your gut should be telling you less. So that's kind of good going into the diagram. So what this says is that the cost of the 100th case of beer for Budweiser was $18. Remember, they just kind of broke even, got a normal profit on the 100th case of beer. It cost $18. So is the social cost, is society's cost higher or lower than 18? Is society's cost higher or lower than 18? Budweiser's cost is $18. What is society's cost? Higher than 18 or lower? Higher, right? So again, Budweiser is a part of society. So the barley, the equipment, the land, all of those costs of production are embodied in the $18 already. And Budweiser is a part of society. So those costs for society are already there. The problem is the three-eyed kid. That cost is not reflected. Budweiser is not paying for their fair share of the air because the air is free. It's causing a problem. So the social cost is somewhere higher. So for the 100th case of beer, it's not 18, it's something higher. So just draw a point that's somewhere higher at the 100th. The same is true then for all units of production, potentially. And so for the 50th unit of production, the cost to Budweiser was this amount, the height of the supply curve, but the cost to society was something higher. For the 150th case of beer, the cost to Budweiser, who's part of society, was here. That's the private cost. But society's cost was something higher because of the pollution. And as we start to kind of play through that logic, you're going to see a curve revealed. And that is the marginal social cost curve. the vertical distance is the amount of the externality, the external cost, the cost that Budweiser's not paying for, the cost of the pollution. So this vertical distance here is the external cost. Okay, so now you might be saying to yourself, but Russ, how do we put a price tag on a third eye on somebody when we're talking about a human being and effect there? And I tell you, well, that's easy. All we have to do is look at the cost of not causing that third eye to appear. So in the example of pollution, there is probably a way to keep that pollution from entering the air. Maybe the company has to install some sophisticated exhaust system that cleans that chemical out of the air before they dump it into the atmosphere, right? So there's a price to that. You see how that then is the extra cost that's missing. That's the missing link here, is we need to make the company pay for the environment, right? What the problem was here is that they were getting to use the air for free. We didn't have property rights associated with the air. Our original thought is, hey, everybody owns the air, we can all use it. Well, that's great until somebody starts overusing or abusing the air to the extent to where their use of the air infringes on a third party's use of the air. Now it's not working. And so we might need some regulation or something in place to say, hey, companies, you can't be doing this. We've got a negative effect that's going on. And ultimately, then, our prediction for the market bears out kind of in the same way we did before, is that the optimal allocatively efficient quantity for society is where the social cost curve intersects the social benefit curve. By default, our baseline assumption is that if there is no consumption externality, the marginal benefit curve for the private individuals drinking beer is the marginal social benefit curve. Those two things, we didn't typically write that, but now we're getting into another level of detail. The marginal benefit curve is the marginal social benefit curve. The problem here is that the marginal private cost curve is not equal to the marginal social cost curve. But where the social cost curves intersect is the allocatively efficient quantity for society. And so here is QAE. Same notation we used before. All I'm doing is I'm putting where the intersection is of the social cost and social benefit curve is the allocatively efficient quantity. And now we get it. Now we see it from the graph that the market is overproducing beer. There's too much of it because it's greater than what the allocatively efficient quantity is. Okay, questions on that? So let me write some of that down. So we need to refine what we did in chapter 2, actually, I think it was. So refining chapter 2. In chapter 2, we didn't exactly call this straight out to your attention, but we were doing this. Marginal benefit equals marginal social benefit equals marginal social cost equals marginal private cost. If you look at all four of those together, we just said, oh, marginal benefit, marginal cost, where they're equal, we get allocative efficiency. But really, allocative efficiency happens right here. That is the true definition. Most of the time, those two things are equal, but they don't have to be, and that's what these externalities are all about. So marginal social benefit equal marginal social cost, that identifies the allocatively efficient quantity for society. That's where we want to be ideally. And what this graph is showing us is that with the pollution from our example, with pollution, the market quantity is greater than what's allocatively efficient. We have an overproduction of beer. Okay. Questions on that? So another place where we have an externality is with education. So it's almost hard to do because we've been doing it for so long. The government has intervened in the marketplace, for good reasons, by the way. But I want you to imagine a market for education. In fact, I think we've maybe put this on the board before. So there's a demand curve. People want to go out and get educated because they might get a job. We have places like Ottawa University that are supplying education. They spend resources. They have a cost of producing the product. The student, you guys, has a benefit of acquiring the education, hopefully to land that big job. These two groups, left all by themselves without any government intervention, would come up with a trade. And the market would have a certain amount of education being produced and consumed, and the tuition would be at some amount, $400. Maybe that's a little light. Maybe we should say $600. Oh, we'll just do it at 400. Okay, so $400 for a credit hour. Yeah, we could use semester or year. It depends on how we define it, right? So I'm thinking maybe a credit hour here or something like that. All right, so what's going on in education? Remember, this is the market all by itself without any interventions or anything. Do you think this is overproduced or underproduced relative to where we'd want to be for society? Under. Okay. So I think we talked about subsidies, or when we brought up subsidies, we looked at education. So society might want to be over here. Why? Because of externalities. Not because we just want you to be smart, but one of the reasons is we might have less crime, we have more productivity, less people in poverty, et cetera, et cetera, et cetera. There might be lots of reasons why we'd like to have people have more education. So, where is the problem? Is it on the consumption side or the production side? Where's the issue, first of all? So is society's benefit equal to the private benefit? Or is there something going on with society's cost relative to the cost that OU has? Where does the externality lie? In consumption or in production? production. So there's not enough of it being produced. There's something wrong with the cost of it. What might keep a person from getting their degree? Money, right? So the person who came for the 100th class was willing to pay $400, and they paid $400, so they got no consumer surplus, right? But these people over here just found it to be too expensive. It wasn't worthwhile, right? The benefit that they were going to get from the education did not exceed the cost of their education. They made a rational decision not to get the education. But from society's standpoint, there's benefits beyond those that the student who didn't come will give to society. So that's our issue here, is that the benefits that the individual gets are greater for society than what just the individual is getting. So let me, I feel like I said the word get too much in there. So if we take this person, the 120th person, they didn't go get an education because they were smart. They took an econ class in high school and pulled out that, well, the cost of an education is greater than the benefit I'm going to get from it, so why do it? But they didn't take into account the fact that that'll cause them not to rob the bank, right? They didn't necessarily think about that, so they didn't think about the other benefits that third parties not directly involved with their individual choice, how they might benefit from them getting an education. Not the least of which might be their future children, by the way, right? There's pretty good data that says if your parents both went to college, there's a better chance that you're going to go to college. So there's some connectivity here in a dynamic sense as well. And so society's benefit is not here with the individual. Society's benefit is higher. So there's a social public good to it that everybody gets to enjoy by you going to school. So there's other people outside of you that are going to enjoy your education. And so the social benefit curve is higher than the private benefit curve. Now, as long as OU is not polluting, like we did with our example, so if there's not something going on with the cost, it costs what it costs. By choosing to build a building here, that's less resources for society in other places. So there's nothing on the face of it wrong with the cost. And so the cost to OU appropriately reflects the cost to society of providing the education. What's allocatively efficient is where these two things intersect each other, which is to the right of where the market is. And so the allocatively efficient quantity is right here. Education is underproduced in the market system because of the positive externality. So the positive consumption externality, with education means that the free market underproduces education. So the market quantity is less than what's allocatively efficient. back in chapter 5, we learned about deadweight loss. And the driving factor of deadweight loss was whenever there was a difference between what's actually getting consumed, which might have been after a tax, after a subsidy. If there's no government involved, then it's the quantity that's out in the market. Anytime there's a difference between what's allocatively efficient and the current quantity being consumed, there's potentially a deadweight loss. So we kind of turn that logic on its head and say, because of the externality, the market is creating a deadweight loss. And it is that triangular region that we saw before. There's benefits to be gained by having more education out there. And so this is the deadweight loss from the market. That's the market failure. And so our challenge is to try to figure out, how can we get rid of that deadweight loss? Are there things we can do? When we did a subsidy in a market that didn't have externalities, the subsidy caused a deadweight loss. Right? Remember that? We had the little triangular region all the time. The government taxed, there was a price floor, price ceiling. Each time the government disturbed the market, it caused an inefficiency. It caused a deadweight loss. Now we're turning that upside down 180 degrees and we're saying, okay, the market's screwed up to begin with. Can we do something to change that result? And so if the government imposes our friendly little subsidy, gets stuck in there, price that consumers pay, price that producers receive, the deadweight loss disappears. So rather than creating a deadweight loss, we're using government policy to remove it. So just the opposite. All right, so that is one thing we'll write. Any questions on that? All right, so so we got, let's see, I already wrote out deadweight loss. No, I didn't. No, I didn't here. So 180-degree turn from chapter 5. 5 and 6 maybe, I can't remember. 180-degree turn from chapter 5 and 6. Recall, government intervention in a market that didn't have any externalities, government intervention created a deadweight loss. Now, if there's an externality, if there is an externality, government intervention may be able to remove the deadweight loss, may lead to an increase in efficiency. Imagine that. Here you thought I was anti-government the whole semester, and it turns out I'm not. There is an appropriate place where we might be able to use policy to make society better. So it might remove the deadweight loss. So what we wrote on the board here was that with the externality, there already is a deadweight loss. So we're going to remove deadweight loss from the market, from the free market. All right, so there is a economist named Pagoo, kind of a fun little name to say. So there's what's called a Pagoovian tax / subsidy. What Pagoo suggested is if we can figure out what that cost or benefit is, then we can set the policy instrument to be equal to it. So with Pagoo, on your pollution example, we would want to set the tax equal to the negative externality, to the external costs. Set tax equal to the external cost. Or, in the case of education, set the subsidy equal to the external benefit. Set the subsidy equal to the external benefit. So I'm not sure if you'd want to muddy up your graph at all, but I just want to show you here when we did the little floating in the subsidy thing, and there'll be some pictures in your textbook too. We float in the subsidies. Subsidies enter in from this side as opposed to coming in from this side like a tax. And we wedge it in there. The top part of the wedge touches the supply curve and tells you the tuition dollars that OU is going to get. So this is the price that the producer, this is the tuition OU gets. The bottom part of the wedge touches the demand curve and tells you the price that the consumer pays, the student. This is the tuition the student pays after getting that government grant or that subsidy or whatever the case is. The effective price of tuition is lower than what OU gets. The difference is the government paying some money in the form of the subsidy. And so there's your subsidy wedge. Again, I don't know if you want to muddy up your graph, but there's the subsidy. That's the amount of government spending that's going towards education. Okay.